Hello students, welcome in your nuclear physics class. In this lecture we will talk about the law of radioactive decay or the Rutherford and Soddy's theory of radioactive disintegration. When a nucleus disintegrates by emitting a particle like alpha particle, beta particle or gamma ray, or by capturing an electron from the atomic shell, you can see the K capture, the process is called radioactive decay. And this decay is a spontaneous process and is independent of the environmental conditions. So Rutherford and Soddy, the name of two scientists, Rutherford and Soddy, they formulated a theory to explain this spontaneous disintegration of the nucleus. According to their theory, every radioactive element constantly disintegrates into fresh radioactive products with the emission of alpha, beta and gamma rays. The new product has entirely new radioactive and chemical properties. This is the one point. Second point is the reaction is spontaneous and can neither be accelerated nor be retarded under any case, but is entirely dependent on the law of chance. The rate of breaking is not affected by the external factors like temperature, pressure, etc. So the rate of disintegration, that means rate of disintegration means number of atoms disintegrates per second. So that means dN by dt is directly proportional to the number of atoms present at that instant. So let that number is n. So dN by dt is directly proportional to n. From here we can write dN by dt is equal to lambda n with negative sign, and lambda is the radioactive constants. From this expression we can write dN by n is equal to minus lambda dt, and if we integrate on both sides, this is log n is equal to minus lambda into t. Now if at time t equal to 0, if at time t is equal to 0, number of atoms is n naught, and at time t equal to t, number of atom is n, then by integrating we will take integral n naught to n, integral 0 to t, lambda is constant. So it will be log n naught to n, and this is t minus 0. So we can write log n by n naught is equal to minus lambda t. From here n by n naught is equal to exponential minus lambda t, or we can write n equal to n naught exponential minus lambda t. So we have the law which suggests that the radioactive decay is exponential in character, exponential minus lambda t. Lambda is disintegration constant. This shows that the radioactive element decays exponentially, and we find out that disintegration is rapid in the beginning and it slows down with time. So if we plot, then it is like initially it is rapid, and then this is 0 at infinite time. So this is the curve between t and n. N is the number of atoms and t is the time. So this is the decay, and initially it is n naught, and it is 0 at t is equal to infinite. Okay, so t is equal to infinite. So from this law we can find out disintegration is rapid in the beginning and it slows down as the time goes. Now we look at the disintegration constant, that means lambda. So as we find out, n is equal to n naught exponential minus lambda t at time for lambda is equal to 1 upon t. We have n equal to n naught exponential minus 1, or we can say n by n equal to n naught by e. E is exponential. So the radioactive constant is the proportional of the time during which the number of the radioactive substance falls to 1 upon e times of its original value. N naught was the number of atoms at time t equal to 0. So as we substitute lambda equal to 1 upon t, then n is equal to n naught upon e. That means the substance value falls to 1 upon e of its original value. So lambda may also be defined as the ratio of the amount of substance disintegrating in unit time to that of the substance present at that time. Now we will look at the half period. So you know, in your junior classes also, half period is the time in which the quantity of radioactive substance is reduced to half of its original value. So we suppose that as we know, n equal to n naught exponential minus lambda t, so we have to find out t in which n changes to n naught by 2. So that means we have to find out the time period t equal to capital T in which n equal to n naught by 2. So we will get n naught by 2 is equal to n naught exponential minus lambda capital T, and from here half equal to exponential minus lambda t. From here we can write exponential lambda t is equal to 2. Taking log on both sides, we have log 2, and sorry, it is capital T, and lambda is equal to log 2 upon t is equal to log 2 upon lambda. So this log 2 is 0.693 upon lambda is equal to t. This is the half period. That means in this time period the number of atoms is reduced to half of its original value. That time period is called half life. This gives the relation between half life and the decay constant lambda. So for the radium, for example, the decay time is half life is 1590 years, and for uranium it is 5000 million years.